Greetings students, welcome to another lesson from iCampSA. In today's lesson we're gonna be doing a past paper question, and this particular paper is from 2019. It was written in November in KZN. The area of focus is trigonometry and trigonometric functions. Let's get into it. Okay, so first thing first, we have question 2. For question 2.1, given that alpha is equal to 24.6 degrees and beta is equal to 132.7 degrees, calculate the value of the following correct to 2 decimal places. Okay, so once they tell you that the answer will be in decimal places, you just know that you'll have to use your calculator. Most of the time you'll have to use a calculator. So for 2.1.1, we have what? 1 over 2 cos alpha. We have 1 over 2 cos alpha. What is alpha? Alpha is 24.6 degrees. Let's substitute that. This is going to be equal to 1 over 2 cos of 24.6 degrees. 24.6 degrees. We punched it in the calculator as it is, so we're gonna have 1 over 2 cos 24.6, and that gives us 0.45, and this is our answer here. Okay, let's go to 2.1.2. we have to calculate cosec 2 beta. For 2.1.2, we have to calculate cosec 2 beta. Okay, and then now we are dealing with reciprocals. Cosec, we know that is a reciprocal of what? Of sine. So this is going to be equal to 1 over sine 2 beta. 1 over sine 2 beta. Okay, and then once we are here, we can actually substitute the value of beta. What is beta? Beta is 132.7 degrees. So this is going to be equal to 1 over sine into 2 multiplied by 132.7 degrees. Okay, and then the answer is gonna be, you punch this in a calculator as it is, 2 sine 2 multiplied by, or you can start by multiplying the 2 with 132.7 degrees, and then the answer is negative 1.00 to 2 decimal places. Okay, and that is 2.1.2. And then next, for question 2.2, what do we have here? Various options are provided as possible answers to the following. Okay, to the following, choose the correct answer and write only the letter A to D next to the question. For example, to the question number. For example, 2.2.4. okay, A, that was the example. Okay, 2.2.1. let me see something quickly. It's 2.2.1. okay, then we have 2.2.2. oh, then we have 2.3. okay, so for 2.2.2, we only have to write the correct answer. Which trigonometric equation could be used to determine the value of angle E? This is our angle E here. That is the angle E. That's the angle E there. Okay, and then what is the angle E? We have the right angle here, which means the side EF, or side 7, which is 17 centimeters, is what? Is the hypotenuse side. So the sine is gonna be 15 opposite over hypotenuse side, which is 17. And then for the cosine, we're gonna have okay, maybe let's just write this. It makes our lives very easy. Cos E is gonna be equal to 8 over 17. Sine E opposite over adjacent is 15 over 17, and then tan E is opposite over adjacent, 15 over 8. 15 over 8. Okay, and then once we have written down everything, we can come here and see which solution gives us the correct answer, and we see that it's going to be solution number C, sorry. So for 2.2.1, correct answer is E. Correct answer is E. That is what was the instruction for this. Okay, let's go to 2.2.2. Okay, so in the diagram below, a scalene triangle element, remember that's a scalene triangle, is the triangle where there is no side that's equal. All sides are not equal. That's a scalene triangle. And angle M is 90 degrees, so it's also a right angle triangle. Which of the following is always true? Which of the following is true? And remember that these two angles, L and N, the angle L and N, they are complementary, which means they also add to 90 degrees. Okay, and complementary angles, we know that sine L is equal to what? Is equal to cos N. Okay, sine L is equal to cos N, and look, that is what we are given there. Okay, maybe before, let's take the same approach we did last time. For sine angle L, this angle here is the opposite over adjacent, so is this side over adjacent is equal to mn over hypotenuse over ln. Okay, and then what is cos L? Cos L is equal to adjacent lm over hypotenuse ln. Okay, and then let's come to angle N. Sine N is equal to what? Is equal to opposite lm over hypotenuse ln. And then what is cos N? Cos N is equal to mn over ln, adjacent. And do come look at this. Look at sine L. The ratio of sine L is what? Is mn over ln, and the ratio of cos N is mn over ln. So those two are basically equal, and that's the thing about the complementary angles. Complementary angles are the the trigonometric ratios. You know, the sine trigonometric ratio of one complementary angle is equal to the cosine of the other trigonometric of the other angle is equal to the cosine trigonometric ratio of the other angle. As you can see here, that sine L is equal to cos N, and then the other ones are also equal. Where cos L, which is lm over ln, is equal to sine N, which is lm over ln. Okay, so let's come here and see which statement is true. So sine L is equal to cos N. Sine L is equal to cos N, and the B seems to be true. So the answer will be 2.2.2. It's B. That is our answer, B. Okay, and then next we have 2.3. Okay, so for 2.3 we're asked to simplify the following without the use of a calculator. So once you're asked to simplify without the use of a calculator, you know that you're gonna be employing what? You're gonna be employing special angles. So we have 2.3. Let's quickly write what we are supposed to simplify, and that is sine squared 45 degrees plus cos squared 45 degrees. Okay, this is essentially a what you call this thing, trig identity, but you'll learn about that in grade 11. For now, let's quickly remind ourselves of the special angles, that give special triangles, that gives us the special angles. So we have the first one, which has 45 degrees and 45 degrees, and we have 1 and 1 and root 2. And the other triangle, the other triangle is the one of this nature. It's an equilateral triangle, so all angles are equal within the triangle. So we have 60 degrees, 60 degrees, and then we have to draw a line from one point that is perpendicular to the other side, and it bisects the side that it is perpendicular to. So this one is perpendicular to this side, so this one and this part will be equal, and it also bisects the angle there, since this is a equilateral triangle. So we're gonna have 30 degrees and 30 degrees here, which adds up towards to 60. And this triangle, since the scaling, all sides are since it is a equilateral triangle, all sides are equal, and they are equal to 2 units. And this one here is also gonna be 2 units, but we're gonna use 1 and 1, since we're gonna use 1 and 1 because 1 plus 1 is what? Is 2. So 1 belongs to each of the bisected side. Okay, and then let's call the line that bisects the triangle, let's call it AB. Line AB, we have to calculate line AB. What is line AB? Line AB is equal to root 3, but in order to calculate line AB, we have to use what? Line AB, we have to use the Pythagoras theorem. We're gonna say AB squared is equal to the hypotenuse, which is 2 squared, minus the adjacent side, which is 1 squared. So this is going to be 4 minus 1, which is 3. Okay, and therefore AB is equal to root 3. This is our AB there, root 3. Okay, then once we are here, we can now use our special angles. And remember, if you have to know this by heart, you have to memorize these special angles, so that you don't have to draw the triangles in the exams, because time is against you at that point. But if you do forget, I will advise that you do actually draw the triangles. So what is sine 45? Sine 45 is going to be 1 over hypotenuse, so 1 over root 2. So we're going to have 1 over root 2 squared, plus what is cos 45 is also 1 over root 2 squared, 1 over root 2 squared. Okay, and 1 over root 2 squared is going to just be what? 1 over 2 plus 1 over 2, and this is equal to half plus half is 1. It's just one whole number, half plus half. Okay, and then next, now solve for x correct to 1 decimal place, where theta is between where x is between 0 degrees and 90 degrees. Okay, so we are asked to solve for x. Okay, so we have sine 2x is equal to 0.291, that is 2.4. So we have 2.4 sine 2x is equal to 0.9 is what, 921 or 291 is equal to 0.291. So to solve for x here, what do? We have to start by transposing sine to the other side. So we're going to be left with 2x here. To transpose sine to the other side, we must use what? We must use the second function, or shift, in our calculator to get sine inverse, of which sine inverse of 0.291. Okay, and then next step is you divide by 2 on both sides, and that should give us the answer for x. Okay, correct to 1 decimal place. Okay, And next you punch that in your calculator, and we see what do we get there. 0.291 over 2. And then x is what? X is equal to 8.46 degrees. 8.46 degrees. 8.46 degrees. That is our x, and it makes sense because remember that we were told that x is between 0 and 90 degrees. Okay, and then for 2.5, let's in fact copy. Let's come here. This is our 2.5. Let's drop, we'll just focus on 2.5. Okay, here. Okay, so for 2.5 in the diagram, P with the coordinate x and root 5 is a point in the Cartesian plane, and P of x is equal to theta. So we are given that PO is 3 units, the terminal arm is 3 units, and we are given root 5, which is stands for the y side, of which stands for the opposite side. We can actually calculate the value of x, or we are essentially told in 2.5.1. let's get into it. Use the diagram without the use of a calculator to determine the value of x. So the value of x, we have to use what? A Pythagoras theorem, because essentially there we can construct a right angle triangle like this, and now we have two sides, of which is this is root 5, and this is your x here. So we are looking for the side of x. So in 2.5.1, I'm gonna say Pythagoras theorem, x squared is equal to r squared minus y squared. What is r squared there? Hypotenuse side, or the terminal arm, is 3 squared minus y squared. What is y squared? Is root 5 squared. Okay, this is x squared. Therefore x squared is equal to, what is 3 squared? That is gonna be 9, minus root 5 squared is gonna be just 5. So 9 minus 5 is gonna be 4. Let's introduce a square root on both sides, a square root. And remember that when you are introducing a square root, you must introduce both the negative and the positive root. Therefore we're gonna have x is equal to 9 minus 5 is 4, so we're gonna have x is equal to square root of 4 is what? Is 2, or x is equal to negative 2. Remember that we have two roots, the negative and the positive root. And let's come here and see. And when you see that the value of x, or x, is located to the left of the y-axis, which means what? It means that x is in the negative, because we have 0, and then when we move in this direction you have a negative. So we'll go with what? We'll go with x is equal to negative 2. X is equal to negative 2. X cannot be equal to 2 because we are in the negative side, which is tangent quadrant 2 and 3. So x is equal to minus 2. Okay, that was 2.5.1. Next we have 2.5.2, which is cos theta. 2.5.2 cos theta. What is cos theta? Cos theta is equal to the opposite side over the adjacent side. So we can say cos theta is equal to, over the hypotenuse is x over r. So cos theta, this is equal to what? Negative 2. What is the value of r? Is 3, the terminal arm. So that is your cos theta. It's gonna be equal to negative 2 over 3. And then next we have 1 minus sin squared theta for 2.5.3. 2.5.3, we have 1 minus sine squared theta. This is going to be equal to, what is sine? Sine is opposites over adjacent. The opposite is root 5. So sine, we have 1 minus y over r squared. Okay, this is actually equal to 1 is equal to, what is the value of y? Is root 5. We have root 5 over 3, root 5 over 3 squared, and this is equal to 1 minus root 5 squared is gonna be 5 over 3 squared is 5 over 9. And then to simplify this further, we're gonna say we keep one denominator, which is 9, and then 9 into 9 is 9 times 1 is going to be 9 minus 5. The answer is going to be 4 over 9. That will be your final answer, 4 over 9. Okay, and then next for 2.6, sketched below are the graphs of f at x is equal to a sine x and g at x is equal to cos x plus b. For x is the element of 0 degrees to 360 degrees. So the range is 0 to 360 degrees. Okay, and then just a few things. We see that the sinusoidal graph, the function f starts from the negative. So what do we expect? We expect the value of a to be what? To be negative. The value of a to be negative, because this graph begins, it has been reflected about the x-axis, because we know that the normal sine function, it goes like this. So once it starts by going into the negative side or starts by going down, it has been reflected. And then let's come here to another thing, to the cosine function. We see it starting from 3 going down, and then going down to -1. So the highest point is 3 and the lowest point is -1. That tells us that this graph has been shifted, the cosine function, and that's why we have the b there. It has been shifted upwards. Okay, so that is that. Let's get into answering the questions. First thing first, we have 2.6.1. 2.6.1. Write down the values of a and b. What is a? A is the coefficient of sine, so that tells us the vertical stretch. How far is the function stretched from the baseline? From the baseline. So this one is what? Is that lowest point is -5. So a is equal to -5. A is equal to -5, and then b is what? Is the vertical shift. So for this graph, how many units has this function been shifted? It has been shifted, I think it's 1 unit. But remember that for the vertical shift, you can always use this formula. b is equal to 1 over 2 into maximum value. Just put max minus minimum value if you are not sure. Okay, so b is equal to 1 over 2. What's the maximum value? It is 3, and the minimum value, this one is 3 minus 1. That's the minimum value. So we're gonna have 3 plus 1 is 4. 4 divided by 2, then the value of b is what? Is 2. That's the value of b. So the function of cosine, the g function, it has been shifted 2 units upwards, as we see that the baseline now of this function goes between 3. Sorry, what have I done here? No, I think I made a mistake. This formula is not actually the one. This one is for the amplitude, to calculate the amplitude. The one for calculating the vertical shift is max plus mean. It's max plus mean. Yeah, sorry, I just realized that I made a mistake there. So it's 1 over 2 max plus mean. Let me put here, this one is for calculating the vertical shift, the one that I wrote there of max minus minimum value is the one for amplitude. So this one is gonna be b 1 over 2 into 3 plus minus 1. Therefore b is what? B is equal to 3 minus 1 is 2. 2 divided by 2 is 1. 2 divided by 2 is 1. And we can see by the baseline that it is somewhere there along the point 1. Okay, and then 2.6.2, we'll write down the period of f. So what is the period? The period is the time it takes for the function to complete one cycle, to complete one cycle. So the f function is a sinusoidal function, and in grade 10 I always say this, 95% of the time, since your functions are not stretched horizontally, the period will be 360 degrees. So period is equal to 360 degrees. Okay, and then 2.6.3, determine the range of g, the cosine function. 2.6.3, remember that for the range we are looking at the y values. What's the minimum value for g is what? Is -1. That's the minimum value, and the maximum value for g is 3. So the function only exists between those two values, the maximum and the minimum, which is -1 and 3. Therefore the range for the g function is saying the range y is the element of from negative why did I put -0 degrees? It's -1 to 3, the maximum value. That gives us our range. The function exists between those 2 points, -1 and 3. Okay, that is the range. And then next, for which values of x is g at x less than 0? Is g at x less than 0? Which values of x is g at x less than 0? Okay, so g at x, let's come here. So we're basically looking for those values of x whereby the function is below the x-axis, and it's these values here. We just have to find what's the x value here and the x value there. Okay, so it seems as if the intervals here are gonna be what? Let's see, I think it's 10. Let's say 10, 20, 30, 40, 50, 60, 70, 80, 90 is 90, 100, 110, 120. There we have 120 degrees, 130, 140, 150, 160, 170, 180. Okay, 180, we're still on track. 190, 200, 210, 220, 280, 240 degrees, 250, 260, 270. Yes, we're on track. So the function of g has values of x which are the values of x for which the function of g is less than 0. Basically, where it says negative, it's those values of x where x is greater than 120 degrees but less than 240 degrees. So for 2.6.4, we're gonna say where x is greater than 120 degrees but less than 240 degrees. Those are the values of x where the function will be negative, less than 0. Okay, 2.6.4. This one was the last question. Okay, this marks the end of today's lesson. I hope you guys learned something from this video, and I hope it prepares you for your examination. Until we meet again, I wish you guys good luck and good studying.